उधर ही कहीं पढ़ो। रवि के पास अपनी बोल रही थी उसको टाइमलाइन बोलो क्या वो टाइमलाइन स्टॉप कर दो यहाँ करेंगे कर दो तुम बस
What is this?
Okay, hi everyone. My name is Qaisar Maqbool. Today I will discuss about the presentation on the Japan bullet magnetic train. So,
मतलब ये सवाल करना था
first of all, I explain something about my outlines, a brief history of Japan bullet train. Then I will explain a wonderful historical video on magnetic bullet train. There are construction parts we will discuss here and required material for the magnetic bullet train. And then we will discuss about the physics behind the magnetic bullet train. And we will see here the mechanism of magnetic bullet train. And then we see here why magnetic train is preferable than other normal trains. Then we will also discuss some challenges of the magnetic bullet train which is facing nowadays. Then we will discuss future research directions in this topic. So, first of all, we see here the historical picture and some information relating to the history. The Japanese people call it the name Shinkansen as the name. But we normally call it magnetic bullet train, but they don't like to call it magnetic bullet train. They just call it Shinkansen train. So it is a high-speed bullet train, and when it is made, the speed of this train was 200 km at that time, and it was inaugurated in 1964. And for the first time when this train was ran on the road, this is made from Tokyo to Osaka. Tokyo is basically the capital of the Japan, and Osaka is also a very populated area of the city of the Japan. So for the first time, the government of the Japan decided to make the track from Tokyo to Osaka. So this is the historical background. There is a video, very interesting, and maybe you will
इधर देखो लैपटॉप की तरफ
So this is the first video which is made by the Japanese government at that time. This is very normal, but this is the track from Tokyo to Osaka. You can check 200 km easily. So today we discuss about the material of the bullet train. So first of all, I will talk about the aluminium alloys. You know very well aluminium is a metal which having the very crucial properties other than metals, because it is very weightless. Mostly our windows and our building materials made by the aluminium, because of its very weightless. So most of the parts of the train is made by the aluminium alloys, right? So if we see that slide, the body of the bullet train was made from the lightweight aluminium alloys. This helped reduce the overall weight of the, because you know when the weight of the any device or any machine is less, then the speed also increases. So they prefer aluminium to make many parts of the train. So the next one is that superconducting magnets. Mostly, there are different types of magnets, but the magnetic bullet train, the Japanese preferred superconducting magnets, because superconducting magnets are those magnets which have very low resistance of electricity passing the mean to say they conduct electricity very low resistance and very low temperature of the tracks or guideways. So superconducting magnets are also used. What is the function of the magnetic superconducting magnets? I will discuss later. And the plastic also used there to make the train. So plastic, mostly the chairs and the other usable things were made with plastics there. And copper is, it is a unique metal because of its properties, thermal properties, electrical properties, and other properties. Most of the electrical work in the magnetic train were made with the help of copper, of the different alloys of copper. Electrical system and wiring in the train would have involved in the use of copper and other conducting materials. So see that picture, manufacturing. This is the virgin carbon fiber, which is the most famous in the history as well. So it is basically fiber-like structures. So in the market, if you want to get this material, it is formed in the rods, not fibers. So when you have a rods, you can melt it with a different temperature, and you can convert into reclaimed form. Reclaimed form, like bubbles. When you choy the bubble, then that shape in this material. So after reclaimed the carbon fiber, you can change you can make any other equipment or any other parts of the train. So this is the very usable material. This material is used a lot of in this situation. So now we discuss what's the physics behind the magnetic bullet train. So this picture is actually explain the physics which is working behind the making to run out the magnetic bullet train. So here is the two main things here. First one is that levitation, and other is propulsion. So this is the two things. First of all, I am talking about levitation. Levitation means to say that levitate any object. So in the manufacturing of train, the scientists main focus this principle of levitation. If you see can you help me with
Pointer?
Yes. This one? Okay. So see, here is the north and here is the north. You know very well, when the same magnets in the same nature come close together, they repel each other. In the same way, the scientists use this phenomena, and they made the track of the train to the north pole, and the same they put a lot of magnet beneath the train. So on the both sides, you see from the picture. So when they manage same magnet up and down, the train lift up. So this phenomena is called levitation. And then you see this other picture, propulsion. Propulsion is basically the pushing of the train. So propulsion train also require a propulsion system to move forward. Linear instructions motor or other electromagnetic propulsion system are used to provide the necessary thrust for the train to accelerate, maintains the speed. After some time, I will show you a very brief video in which you see the same phenomena in the video. Then you will get a clear concept about it, right? So here, this is the main scientist who made this train for the first time.
हिरोशिमा ने किया था तो एक जापानीज इंजीनियर
Wait a second.